Okay, this video is on sigma notation. Now, sigma notation is a particular kind of notation that we use when we want to add up a whole bunch of different terms, like we might do in a series. And sigma notation, it starts out with this big uppercase sigma, and then there's some other pieces to the notation. The first piece is what we're going to call a sub I, and this piece of the sigma notation, this just tells us that the terms we're going to be adding are a sub 1, a sub 2, a sub 3, and so on. All right? And this little subscript I, the way we know that this starts with 1 and then goes 2, 3, and so on, the second part of the sigma notation tells us which term in our series we start with. So typically we start with the first term. You don't always, but so down here you'll see the little indicator I equals some number. In this case it's I equals 1, and this tells us the sum this tells us that the sum starts at a sub 1. All right, the 1 is the first number here in the series. There's a number also up here at the top, and that number, we'll just call it n for now, but that's going to be some number. This number up here at the top, this tells us where the sum ends. All right, so in particular, this number tells us the sum ends with a sub n. All right. So in other words, this is a kind of a general way that the notation looks, and we're going to see how these each of these three pieces of it are going to look a little different depending on the particular series that we're going to be adding. So, but this one in general, if we were to write out this sigma notation, if we were to expand it, then all this would look like if we said sigma I equals 1 to n of a sub I. Well, if we expanded that out, all this would mean would be a sub 1 plus a sub 2 plus a sub 3, and then we'd keep on going until we got to a sub n, and then we would be done. All right. So let's take a look at what sigma notation is going to look like with an actual problem. In the example in your notes it says use sigma notation to express the sum of the first 20 positive odd numbers. Okay, so the first thing I want to note about this is that if I'm talking about the sum of the first 20 positive odd numbers, well, the first 20 positive odd numbers, that's just an arithmetic sequence like we've already looked at. And the arithmetic sequence we could write as, since the first 20 positive odd numbers, that would be 1, 3, 5, 7, and so on, up to the 20th odd number. Well, I noticed that for this particular arithmetic sequence, a sub 1, the first term, is 1, and d, that is our constant difference between the terms, is equal to 2. Well, I remembered that I can write down a formula, called an explicit formula, for the nth term in the sequence. Well, that's going to be very handy because that formula is what we're going to use in our sigma notation, as we're going to see in just a minute. So let's go ahead and write that down. If I want to write down the explicit formula for a sub n, the nth term in the sequence, then I remember this formula is a sub 1 plus n minus 1 times d. And this would be equal to, a sub 1 for this arithmetic sequence is 1. So that would be 1 plus n minus 1 times 2. All right, so this is my formula for the nth term of my arithmetic sequence. But now I'm going to make one change here, because for my sigma notation, remember, I don't want a formula for a sub n. What I actually want is a formula for a sub I And this seems like a small thing because we're just talking about, well, it's the difference between, using the variable n or using the variable I, but we're going to see that that kind of becomes important. We're going to use a sub I. So basically, I just want to rewrite this. I want to say a sub I. Instead of talking about a sub n, I'm going to use a sub I. So I'm just going to replace the variable n with the variable I, which means I've got 1 plus, instead of n minus 1, I'm going to use I minus 1 times 2. Right? So now I have this formula here for a sub I. And let me go ahead and write this out. I've got 1 plus I minus 1 times 2. Let me go ahead and simplify this a little bit. That's going to be 1 plus, and if I expand this, I'm going to use my distributive property here. Let's see, that's going to be 1 plus 2I minus 2, and positive 1 and negative 2, I can combine those, and that gives me 2I minus 1. So here I have an expression for a sub I. Now I can write, using sigma notation, I can write this sum of the first 20 positive odd numbers. So my sigma notation, remember, looks like this. A sub I equals 1 to n. Well, I just need to figure out what values are going to go here in these three different places for my sigma notation. Well, a sub I just figured out, is 2I minus 1. I'm starting with my first, I'm going to start with my first term, so I'm starting with I equals 1. And I'm going to go up to the, in this case, 20th term. I want the first 20 terms, so n is going to be 20. And this is how I would use sigma notation to express the sum of the first 20, that is 1 through 20, of the odd numbers, which are represented by 2I minus 1. Each one of those is the ith odd number. And I can check this fairly easily. The first number, if I want to say, well, my first term is just going to be, I take I equals 1 and plug it in here, 2 times 1 minus 1, that's 2 minus 1, my first term is 1. My second term, I let I equal 2, so my second term is going to be 2 times 2 minus 1, that's 4 minus 1, which is 3. My third term, I just let I be equal to 3, so my third term is going to be 2 times 3 minus 1. That's 6 minus 1, which is 5. And I can see my first, second, third term, they are in fact the first 3 terms of the positive odd numbers. If I keep going, I'm just going to get each additional odd number, and I just go all the way up to 20, and this indicates the sum of those first 20 terms.